Today, we are going to learn how to correctly write a chemical equation to represent a chemical reaction. Let's start by looking at a familiar chemical reaction, the burning of magnesium. As you can see in the video, magnesium has a silverish color, appears quite shiny and very malleable. Silver, shiny, malleable are examples of physical properties, characteristics that can be observed without altering the identity of the substance. Magnesium also has the chemical property that it burns very easily with the help of a small amount of heat produced by the matchstick. Burning is a chemical property. Chemical property can only be observed by altering the substance, changing it into something new. As the magnesium burns, it changes into a whitish substance that is quite brittle, called magnesium oxide. It no longer has the original physical properties of magnesium, like silver, and its chemical property has also changed. As magnesium oxide, it is no longer combustible, unlike the original magnesium strip. We can represent this chemical reaction by writing an equation, a chemical equation, that looks like this. Magnesium plus oxygen yields magnesium oxide. The two symbols on the left of the equation are the reactants of this chemical reaction. On the right side of the equation, magnesium oxide is the product of the reaction. This chemical reaction will occur with the help of a small amount of heat from the matchstick. This input energy to start the reaction is called an activation energy. Once the reaction starts, once the burning starts, it will produce a lot of heat and light. This is called an exothermic reaction because more energy is given off than the original input energy. The reaction, the burning, gives off lots of heat and light, lots amount of energy. The law of conservation states that in a chemical reaction, you must have the same number of each type of atom in the reactant as in the product, so that the number of atoms of magnesium at the beginning and the number of atoms of oxygen at the beginning must be present in the product. So right now the equation is written incorrectly. To help us fix this equation, let's draw spheres to see what's happening with the atom. Black sphere representing a magnesium atom, and two blue spheres representing an oxygen molecule, chemically bounded together, forming a molecule. During this reaction, the oxygen molecule splits apart, breaking a chemical bond. A magnesium atom joins with an oxygen atom, forming a new chemical bond, producing a substance called magnesium oxide. A second magnesium atom will join with the oxygen atom, once again forming a substance called magnesium oxide. So during this reaction, two magnesium atoms are needed to combine with an oxygen molecule, producing two magnesium oxides. To indicate two magnesium atoms, we put the coefficient 2 in front of the symbol magnesium. We only need one oxygen molecule. We do not need to write the number 1 as a coefficient in front of O2. On the right of the equation, as a product, we made two magnesium oxides. We add the number 2 coefficient in front of the formula magnesium oxide. Now, the equation is written correctly. two magnesium atoms combined with an oxygen molecule yields two magnesium oxide. Law of conservation of mass means that if we start off with 30 grams of magnesium and 16 grams of oxygen, as magnesium burns, combines with oxygen, we must produce 46 grams of magnesium oxide because every single atom is accounted for in the product. During a chemical reaction or a chemical change, molecules break chemical bonds and atoms reassemble, forming new chemical bonds, making new substances.